Hey everybody, Mr. Zamora here. What we're going to do today is talk about binomial expansion with Pascal's triangle, and we're only going to use Pascal's triangle in this video. Now, Pascal's triangle is a term in which the binomial expansion can be written in many coefficients and many different numbers. There's infinitely many when it comes to expanding a binomial, but in this case I'm only going to be talking about rows 0 through 5. So before we start these 4 questions that I have right here, what I'm going to do is I'm actually going to pre-write Pascal's triangle, and I recommend to my students that they do this as well. So the first thing that I'm going to do is that this is technically row 0, and I'm just going to put a 1 there, and that's going to work every time. Now, this is a rookie mistake that some people, including myself, have sometimes made. A lot of people think that this is actually row 1, but this is actually row 0, because if I were to take x plus y, for example, and raise that to the 0 power, well, we know that anything raised to the 0 power in terms of exponents is going to be a 1, and that's the solution that we're going to get right here. So this is row 0, so I'm going to write row 1. In this case, there's going to be a 1 right here and another 1 right there, so that's going to be row 1. And now to expand upon that, to get to row 2, now every single row, it's important to note that at the front and on the end, I guess you can say, of each and every single row, there's always going to be a 1 right here on the left side, and then there's always going to be a 1 right here on the right side, every single time. Now, to get to the middle number right here, what I'm going to do is look at the previous row, and I'm going to add these two numbers together. So 1 plus 1 is going to be 2, so I'm going to put that there. So that's going to be row 2. So now I'm going to write row 3 here. I should probably expand on my triangle here, but that's okay. I'll do that later. So we have another 1 and a 1 right here. So now what I'm going to do is that I'm going to go left to right in terms of all of these numbers to fill in the middle space right here. So that's going to be 1 plus 2, so that's going to be 3, and then 2 plus 1 is going to be another 3. So that's row 3. I'm just going to write that there just so that way nobody gets confused. So now I'm going to try row 4. So 1 and 1. So 1 plus 3 is going to be a 4, 3 plus 3 is going to be a 6, and then 3 plus 1, that's going to be another 4. So I'm going to just expand that just a little bit. So it looks like I'm going to make a triangular prism, or it looks like a pyramid there. But let's pretend that that line doesn't actually exist here. So that's going to be row 4. And now let's do row 5. So 1 and 1. So we're going to add these two together like we're reading a book. So 1 plus 4, that's going to be a 5. 4 plus 6, that's a 10. 6 plus 4, that's another 10. 4 plus 1, that's going to be a 5. All right, so that's row 5 here. Now, like I said, there are infinitely many other rows, but I'm just going to go over 5 today. So keep that in mind, and let's figure out number 1 here. So we're asked to expand upon x plus 5 raised to the 3rd power, or x plus 5 cubed. Now, before we start anything, it's important to analyze a binomial right here. So I'm going to look at this 3 here. Now, the 3, or in this case, any power of an exponent, actually corresponds to the number of row that it's going to be in. So because this is raised to the 3rd power, that's going to correlate with row 3. And we know that the 4 coefficients in row 3 is 1, 3, 3, and 1. So now that I have that information, what I'm going to do is that I am actually going to do this here. So the first term that I'm going to use is going to be x, and I'm going to raise that to the 3rd power, and I'm going to take this 5 here and raise that to the 0 power. Now this part actually here is optional. You don't have to do this if you don't want to, because it's not going to make a difference in the ultimate outcome of this expanded binomial. But I'm only doing this to show the example, and later on I won't actually include this because it's not really going to make a difference. So we already have that one, so that's the first row, or that's the first number of that row, so we can check that off. And then I'm going to add, and then I'm going to times that by 3 because that's the coefficient right here. So what I'm going to do here is that I'm going to do x, and now I'm going to actually drop a power value, and what I'm going to do is I'm going to take that power value and put that upon this 5 right here, because you'll notice that 3 plus 0 is 3, and 2 plus 1, that's also a 3. So as I keep expanding on, the important thing to note is that when it comes to the linear term, every single time you add or subtract or whatever, you always have to subtract one value, and whatever the constant is, which we know is 5, we're actually going to add one value on that. So say 0, 1. So you can assume that for this part right here, so we have this 3, so this is just going to be x raised to the 1 power, and then I'm going to add 5, and I'm going to square that there. All right. So we have the 3, we have this other 3, and now we're just left with this 5, and we're going to raise it to the third power. Now that is our ultimate goal. As long as the start is with 3 and that the end value is raised to the third power, we know we've done this right. So luckily for you guys, I've actually pre-did these questions, so that way I won't have to figure out the complicated multiplication. So what I'm going to do here, we have x cubed times 5 raised to the 0 power. Well, that's just going to be 1. So like I said, that's not going to make a difference in this case. So we have x cubed, and then we're going to add, this is going to be, okay, so 3 times 5, that's going to give us a 15. We also have that x squared right there. And then I'm going to add, okay, so let's see, what do we have here? So that's going to be 75x. And then we also have plus 125, which is 5 times 5 times 5 in this case, okay? Oh, it looks like I made a little bit of an error right there. This is not actually going to be added. This is all going to be multiplied there, my mistake. All right, so that is the final solution when it comes to this. All right, now let's do one that has 2 values. Now, even if it has 2 values, that actually doesn't make a difference. The only difference it's going to make is that it's just going to have an extra value in the solution, but no problem. So we're asked to expand 2x minus y to the 4th power. Okay, well, let's look at this exponent here. So that's going to be to the 4th power, so we know that's going to correlate with the 4th row. And what do we know about the 4th row? Well, if we look back at the triangle right here, that's going to be 1, 4, 6, 4, and a 1. Okay, so let's think about this here. So the first value is going to be 2x raised to the 4th power. Now, if you wanted to, you could include a negative y to the 0, but you don't really need to, because like I said, every time you raise something to the 0 power, it's just always going to be 1. So now I'm going to do, so we're already finished with that one here. Treat these as coefficients. That's a good way of putting it. So we have 4 times 2x, and now instead of adding that number or adding a value, we're going to subtract that value. So 4 minus 1 is going to be 3, and then that's going to be minus y raised to the 1st power, because we're going to add a value to whatever that second coefficient or constant or linear term is going to be. So now we have times 6 times 2x, drop a value, so that's going to be 2, and that's going to be negative y, add a value, that's going to be 2, and then we're going to have times 4 times 2x raised to the 1st power, and then multiply that by a negative y, and we're going to cube that. And then we should end up with negative y to the 4th power. Okay, perfect. All right, so now once again, I've pre-done this one, so that way we won't have to go through the complicated multiplication here. So if you combine like terms and everything like that in terms of exponents, you're gonna get 16x to the 4th minus a 32x cubed. Now you'll notice that I added all of these because I really don't want to have the value of like subtracting it. I always put the addition there because then we can see like, oh yeah, you know, because if you did like a negative and then another negative, it might be a little bit confusing. It might throw some people off. So I always recommend to my students that you just add them up because it'll be a little bit easier. All right, so negative 32x cubed times y plus, that's going to be a 24 x squared y squared minus 8x y cubed, pardon the big hand in the way, my bad, plus y to the 4th. Okay, so that's the solution for that. We have expanded upon that. See, we didn't even have to distribute. Isn't that awesome? All right, so let's go on to number 3 here. All right, so we're asked to expand x minus 2 to the 5th power. Okay, well, we know that the 5th row, we know that it's going to be the 5th row because that's the exponent that it's based off of. And what do we know about the 5th row? What are the coefficients? Well, it's 1, 5, 10, 10, another 5, and a 1. Okay? All right, so now let's work with what we have here. So we're going to start off with x. It's going to be x to the 5th power times a negative 2 to the 0. Once again, you don't have to write this if you don't want to. That's going to be plus the coefficient, so we're already finished with that one. We're going to focus on the next coefficient of this 5, so that's going to be 5 times x to the 4th minus a negative 2 raised to the 1st plus 10. I'm going to put that in parentheses, 10 raised to the x cubed. You'll notice that we are subtracting values from x and adding one power term to the constant here. So that's going to be negative 2 squared and then that's going to be plus 10 times x squared times a negative 2 raised to the third power plus, oh, I'm running out of room here. We have a 5 times an x raised to the first times a negative 2 raised to the fourth plus, I'm going to go over here, a negative 2 raised to the 5. Okay? So if you add all the combined like terms and everything like that, you should get a value of x to the fifth minus a 10x to the fourth plus 40x cubed minus 80x squared plus 80x minus a 32. Okay? So we have all that together. All right, so now the last one here. So it's asking us to expand upon x plus 2y cubed. All right, well, let's figure this out. So we have to look at the exponent. We know that that's going to correlate to the third row. And what do we know about the third row in terms of the coefficients? Well, we know that that's 1, 3, 3, and 1. All right. Now let's do the exact same process we've done for the previous one. So I'm going to take this x, I'm going to raise it to the third. I'm going to take this 2y, raise it to the 0. Once again, you don't have to do that if you don't want to. So we already finished that coefficient. Now let's move on to this 3. So 3 times, actually that's going to be an x, raised to the second power, because we're going to subtract a value from the first term and add another power to the second one. 2y to the first, plus, that's going to be 3 times x times 2y squared, and then we should end up with plus 2y cubed. Okay? Now we're just going to clean all this up and simplify. So this is just going to be a 1. So we're left with x cubed plus 6x squared y plus a 12xy squared, and then we should end up with an 8y cubed. Okay? And then you're finished. So those are the basics of Pascal's triangle. As long as you take, it does take a little bit of process to work it out and everything like that. And as long as you know the coefficients and all that stuff, you really should be good to go. But it does take a lot of time and it does take a little bit of effort. But after a while, it becomes a breeze. It becomes like riding a bike when you think about it. So anyways, I thank you for watching this video. I shall see you soon.